Alright guys, welcome to Solving Systems Algebraically Part 2. So in the last exercise on the video we started with substitution, but today we're going to use algebraic means, and we're going to call this algebraic means, we're going to call this elimination. So this whole thing is about elimination, another way we can solve linear systems. Okay, so let's for example, look at solve the system 4x minus 2y equals 7 and x plus 2y equals 3. So both are in standard form. There's not one I really could solve for y very easily. So I'm not going to use graphing and I'm not going to use substitution because those are going to be more challenging. So we have this other idea called elimination. And so what we can do here is if we look at these two values here, we look at them and they say they're additive inverses. So what we're going to do here is we're going to actually add these two equations together in our system. So here's 4x minus 2y equals 7 and x plus 2y equals 3. So let's go ahead and add them, because what's going to happen is this whole idea of elimination, we're going to eliminate a variable. So 4x plus x is 5x's, okay? Negative 2y plus 2y is 0y, so that's eliminated, that's 0y, and we get 7 plus 3, which is equal to 10. Okay, so now we're left with 5x equals 10, so that means by dividing each side by 5, we're left with x equals 2. So we're halfway there. So now I just have to pick which equation I'm going to substitute back in for. I'm going to use the second equation because there's no subtraction and the values are smaller. So I'm going to use an equation that I didn't use before. Okay, so let's look. We're going to have x plus 2y equals 3. So now by substitution in for x, I can now solve for y because I will have an equation in one variable. My x value is 2, so I'll put 2 there. And then I get 2 plus 2y equals 3, so 2 plus 2y equals 3. That means 2y equals 1 after we subtract 2 from both sides. So y equals 1/2. And so the solution is simply 2 comma 1/2. So we might have been able to get that graphing. We probably could have. It's not too bad with the ordered pairs, but it was just easier to use elimination. So let's look at another example. Now in this example, to solve the system 3x minus 2y and equals 14 and 2x plus 2y equals 6. So again, I can use elimination right away, and I know that if I add the two equations, I can eliminate my y value. So it's important to look, the first thing you do is to see which variable you want to eliminate. Okay? And you want to eliminate the variable that doesn't take as much work. So let's add these together. So there's our additive inverses right here. Okay? So we're going to have 5x now plus 0y, I'm not going to write that, equals 14 plus 6 is 20. So that means x is equal to 4 if we divide each side by 5. Now, I have to find my y value by plugging my x into one of these two equations. I'm going to pick the second one because the numbers are smaller. 2x plus 2y equals 6. So I know what my x value is. It's 4, so it's going to go ahead and plug that in. I'm going to rewrite everything else. So I plug 4 in for x. I'm left with 8 plus 2y equals 6. So that means 2y equals negative 2 and y equals negative 1. So my solution to this system, it's another unique solution, they intersect, is 4 comma negative 1. Now again, elimination in this case is nice. I could have gotten my solution by graphing, but these are a little bit easier since 3 is not a multiple, or not 14 is not divisible by 3. So it might make it a little bit trickier to try to do this by intercepts. Okay, so graphing might take a little bit longer. So elimination was the quicker method in order to do this. So in these first two examples, I've just been able to add these two equations and something subtracts. Okay, now let's look at this system. We have 4x plus 9y equals 1 and 4x plus 6y equals negative 2. So I can rewrite this system, and I see my two leading terms, my x terms, are the same. Okay, so instead of adding these two systems, or these two equations of this system, I can simply just subtract them. And you want to be very careful when you subtract. So we're going to subtract here. And what we have is 4x minus 4x is 0x's. 9y minus 6y is 3y. And 1 minus negative 2 becomes 3. So in this case, we have y is going to be equal to 1. Now in this case, I solve for y. I'm going to pick this first equation. I'm going to write that again. So I've solved for y. That means now I have to find x. So what I'm going to do is plug in, what I know for my y value. I put parentheses around. I was so used to plugging in for x. So we got 1 in for y equals 1. So that means 4x plus 9 equals 1. So that means 4x equals negative 8. Once I subtract 9 from both sides, divide each side by 4, and I'm left with x equals negative 2. So my solution, now you want to be careful. We found y first, so don't get in the habit of putting y first. Our solution is negative 2 comma 1 for this system. So these first three examples have been really nice, really easy to handle, but what happens if you can't just add or subtract right away? So let's look at this system. We have solved the system, 3x plus 7y equals 15. And then the other equation of the system is 5x plus 2y equals negative 4. Now, we can't just add them together because we would not eliminate one of the variables, and that's why they call this the elimination method. We're looking to eliminate one of the variables. So what we have to do now is look to see if we can find a common number that two of these go into, a common number. So let's look. I know that if I want to eliminate a variable, I have to pick which one I want to eliminate, and I'm going to eliminate the y term, okay? Because we know that 7 and 2 are both factors of 14. So that means I'm going to multiply the top equation, that whole thing, by 2, and then the bottom equation is going to get multiplied by 7. Excuse me, negative 7. We want to make them inverses. So this is what we get, our two new equations of our system. So we get 6x plus 14y equals 30. And then when we multiply everything in the second expression by negative 7, we get negative 35x minus 14y, now we have added inverses, plus 28. Now we can add the two systems together, and we should be left with negative 29x's, 14y plus negative 14y is 0, so we've eliminated the y terms. There's that elimination method. And 30 plus 28 gives us 58. So now when we divide each side by negative 29, we get x is equal to 2. Excuse me, x is equal to negative 2. So I got my x. So now I need to find my y value. Okay, so I'll kind of go over here and pick my equation and use this space, and let's see. Let's use 3x plus 7y equals 15. It's very important that we pick something from the original, one of the original two equations, to find our y value. Okay, equals 15, and we know that x is negative 2, and so let's get our answer here. We have negative 6 plus 7y equals 15. So that means 7y equals 21 when we add 6 to both sides, so y equals 3 when you divide each side by 7. So our solution is negative 2 comma 3. Okay. Now, again, in our last example, we have solved the system, and there should be, I'm already seeing there should be an x here. So let's go ahead and rewrite our system. Negative 3x plus 5y equals 7, and 6x minus 10y equals negative 14. So I forgot the x there with the negative 3. So now I look and I notice that in the first variables here, the x's, they're opposite sign. So if I multiply the top by 2, we would be able to eliminate the x's. So I multiply everything in the top by 2, so I get negative 6x plus 10y equals 14. Then underneath we get 6x minus 10y equals negative 14. Boy, these look the same except they're opposite signs. Adding everything together, we have everything as being additive inverses. Everything is an additive inverse, so we get 0 equals 0. That's a true statement. So the solution to this system is all real numbers. These coincide, okay? These equations coincide, meaning they're the same equation. So the solution set is all real numbers, okay? Now, if you get something similar to this when they have a number like 0 equals 0, this is a true statement. But if we get something like negative 3 equals 2 or negative 3 equals 0, when this statement doesn't match up, that means the lines are parallel and there'd be no solutions. So this is how we solve systems algebraically using elimination. If you guys have any questions or comments, you can type them below, or you can go ahead and email me, and that'll pop up on the top screen there. We'll see you next time.